Okay, to set up a TypeScript compiler, you first want to stop your Babel compiler and create a new project. You could do Control-C and stop this, but if I just close down Visual Studio Code, then I should be fine. It will automatically close out that console window and kill off any processes inside of that. And let's look at setting up a TypeScript demos project. So I'm going to make a directory called TypeScript demos. So I'll do TypeScript demos. I said singular here, but we'll go with plural. And then I want to open that in Visual Studio Code. And we saw all the different ways to do that previously. I'm just going to drag it onto my Visual Studio Code off the screen here, and then it will open in Visual Studio Code. So we've got a folder there. Let's get our directions kind of lined up again here. And what we need to go through the same process. So we're going to npm init the project, and then we're going to install TypeScript, a specific version. So let me go ahead and do that. You're probably fine installing a newer version of TypeScript. You might get just a little bit of nuance in some of the demonstrations, but just to be safe, if you have any problems, go back to TypeScript 3.1.6 here. So it created my package.json file when I ran that npm init command. It hasn't run this npm install command to install TypeScript yet, so I'll go ahead and run that. Notice that I'm saving it as a dev dependency. So TypeScript gets added here. Next, I will open a command prompt or terminal and run the TypeScript compiler with the init command. So the init command, what it does in TypeScript is basically creates a tsconfig.json file. So you could just run the TypeScript compiler here, and it has roughly 80, you'll see command line options, probably more than that, and you'd pass them, blah blah flag, another flag, another flag, and that gets old pretty fast and hard to maintain. So all this tsconfig.json file is a way to pass those command line arguments through a configuration file. So if we open that up, we can see there are tons of options here, and these aren't all of them. For the TypeScript compiler, you'll see that we're already targeting ES5, so we should see, writing similar code, we should see that translate right away. So I believe that's what we're going to do. We are going to flip a couple of these options to not quite as strict. Here is a link to all the compiler options that are available for the TypeScript compiler and what all of them mean. What I'm going to do here, just to kind of slowly get us into using types instead of, kind of requiring us immediately to start using types, I'm going to set strict equal to false. Now, if you're used to strongly typed languages that require you to say what types you're declaring variables as and parameters, then this won't feel right to you. Setting strict equal to false, you'll be like, no, I want this as strict as possible. But understand this, that doesn't mean that all the strictness is turned off if you turn that to false. What it is it's a convenient setting to set every strict setting. If the settings were on 1 to 10, like a volume knob, right? And you could turn it up to 10. This turning strict to true really turns it up to like 12. And so what I'm doing in here is I'm leaving a lot of the strict options on, the defaults that are as they're set in TypeScript, but I'm not turning all of them on. So I'm not turning it up to 12 on a 10 scale. So we've got strict equals false. And the other thing we're going to modify is we're going to set no emit on error to true. And this is one you probably want to set when you start using TypeScript. It will actually still output a file regardless of whether the compiler is throwing errors or not. So it'll still output a JavaScript file from the TS file that you write. We'll see how that works in a second, regardless. And that throws a lot of people off. Usually if you're starting on a greenfield or a new project, you definitely want to set this setting to true, no emit on error to true. If you are migrating some existing code, it might be convenient for you to leave this to false initially. As you start to use TypeScript in your project, it won't be quite as onerous. And there's more detail here about why they don't set this to true by default, but it really comes down to the fact that they don't look at TypeScript as the center of the universe. When it first came out, it's becoming very, very popular now. But there was a time when TypeScript had to win over popularity of JavaScript programmers quite a bit more. And that still exists to some degree. And during that time, they wanted them to be able to take an existing code base of a bunch of, let's say, hundreds or thousands of JavaScript files, just rename them to TS, and for the code to compile and for their project to work, and then they could gradually use the features of TypeScript in their project as they needed to, instead of they turn the TypeScript compiler on in their project and immediately they have to go fix a ton of different places in their code. So you can read up a little bit more about that, but let's go ahead and create a program.ts file. In this example, we're not going to put this in a source directory like we did in the last example. We'll just create program.ts here right at the root of the project. I'll go ahead and write a function in there. One thing you'll notice, Visual Studio Code has these nice code snippets, so I could just say function, but that's just going to fill out function for me. If I say function and choose this code snippet piece, it will kind of auto fill in a function for me. So then I can say, oh, this is called greeter. It has a parameter of name. The type is a TypeScript feature called type annotations that we're going to go over in a second. Let me just undo that. And then you can kind of fill things out. In here, what I'm going to do is log out. And if I say console.log, you'll start to see the difference in TypeScript almost immediately. You get IntelliSense and good IntelliSense for all the methods. You may not have realized that that console.log has this specific method signature. You probably used it a ton of times, but it has all these optional parameters at the end. So if I say console.log, and then it says, oh, do you want to pass a message? Well, yes, I would like to pass a message. I'm going to say hi, put a little space in there, and then concatenate on the name. And then down here, I will need to call greeter. You notice as soon as I start typing greeter, it says, oh, did you want this greeter function? Yes, I did, right? And then I'm going to invoke it, and it says, oh, when you invoke it, you need a name. So I'll go ahead and put my name in there and complete that. And now we have some code that we can run through the TypeScript compiler and see how it runs. So if I run the command npm tsx-w, so this again is going to find the version of the TypeScript compiler that lives in this project. In other words, it's going to be sure to use TypeScript 3.1.6. So very similar to what I showed you with npm scripts earlier. We could create a script here. This is just a little more straightforward when we're first learning this. So I can say npx TypeScript compiler and put it in watch mode. So -w, we could have written that out --watch, and it's going to do the same thing that the Babel compiler did. It's going to watch for TS files in this case, and anytime one of them changes, file timestamp changes, then it's going to write a program.js file. So now let's take a look at these two files kind of next to each other. And you'll see a similar thing to what we saw with Babel. You see program.ts beforehand and program.ts afterwards. Let me write the same example that we did with Babel so we can see that this is working, because right now the code we've written doesn't use any new JavaScript language features. So what comes out the other side is exactly the same code. So the compiler has really done nothing to the code in this case. Let's just make sure that this is running, and the way we can do that is the way that you could run program.js itself is we could open another command prompt. There's a couple ways to do that. We could hit plus here, but then that opens a new terminal and we'd have to switch kind of back and forth between the terminal windows here. So instead, what I like to do is use this split icon right here. It says split terminal, and I'll open another window over here. And remember back to what Node.js is. Node.js is a runtime for JavaScript files. So if I say node and I pass program.js, it will execute that code and say hi Craig or hi Ben, as I show in this example. Just for completeness, let's go back up to our Babel example, and we have a block of code here. And let's see what happens when we paste that code in here. What we should see on this side is the same thing we saw on the Babel side, which is const will get converted over to var. If you're confused about the const and the var thing, or the let keyword you may have heard of, we're going to go over that in the very next section, where we learn the details about some of these key new language features that you'll need to use when writing a React app. And we'll go over those next.